Hello. So here we are again, solving where to solve for problems, and this time our chapter is elasticity. Diretso na tayo, ating patagalin. So this is our problem number 1. Um, a steel cable whose cross-sectional area is 1 inch squared is used to support an elevator cab weighing 5 kips. If the stress in the cable is not to exceed 20% of the cable's elastic limit of 40 kilopounds per square inch, or KSI, find the maximum permissible acceleration. Okay, for our first problem, it is said that in an elevator cab, steel cables are used. Now, ang sinabi lang dito, isa lang yung steel cable na may cross-section area ng 1 inch square. The weight of the elevator cab is 5 kips. The condition of which is if the stress the cable will experience is not to exceed 20% of the steel's elastic limit, ano ang maximum allowable upward acceleration. So, mahalaga dito na kahit paano mag-illustrate tayo. Ano ba yung more or less ang itsura ng figure ng problem? So, ang sinasabi lang sa atin is that parang say, this being your elevator cab, it is lifted upward gamit ang cable. Ang cable. Now, ang sabi sa atin, ito ay may bigat na ang weight ng cab ay 5 kips, meaning 50,000 pounds. Tapos, yung cross-section area ng steel cable ay 1 inch square. Now, ang sabi, kung ang stress daw ay hindi lalampas sa 20% ng kanyang elastic limit, nagkataon ang elastic limit niya ay magkano? The elastic limit of that is 40 KSI or 40,000 pounds per square inch. So lumalabas na ang stress would have to be 8,000. Stress pounds per inch square. Ang tinatanong sa atin, ano ang maximum acceleration? Because we don't understand, kapag yun ay hinatak pataas, mas mabilis na atak would result to a greater tension para sa cable. So, ang sinasabi sa atin, provided na nilalabas standard set 8,000 pounds per square inch, the stress experienced by the rope or the cable, ano yung pinakamabilis na pwede acceleration? Upward. So, to start, we need to solve for the amount of force. Bakit? Kasi if we are to place the formula for stress. Stress is force divided by the area, the cross-sectional area. So since given naman ang cross-sectional area ng stress, we can solve for magkano ba yung maximum force na na-produce yung force dito called tension. Magkano ba yung tension yan? Yung force na yun will have to be tensile. That will be the product of stress and the cross-sectional area of the cable. Solvable na yun. Yung force na nararanasan niya ay siyempre 8,000 pounds multiplied by the cross-section per square inch multiplied by the cross-sectional area 1 inch square. So, cancel na yan, multiply, lalabas na yung force ay 8,000 pounds. That would be the maximum tension the cable will experience. Kasi beyond that, that would have to be the stress more than 20% of the elastic limit. So, hanggang dito na ito yung maximum. Now, this would have to be the maximum tension. Maximum tension. Now, so what? Kung nakuha natin yung F, since ang hinahanap ng acceleration, so solve natin ang F, coming from Newton's second law of motion, tsaka na force is equivalent to product of mass and acceleration. So solving for acceleration would have to be force divided by the mass. Mass ng no cab. So using this formula, makuha natin yung ginatawag natin A max. The maximum acceleration has to be the force that is 8,000 pounds divided by the mass of the cab. Now, ano ba yung mass ng cab? Ang meron tayo yung weight ng cab. Huwag natin yan. Knowing na ang weight ay mg, makuha natin ang mass bilang weight. Mass of the cab is the weight of the cab over acceleration due to gravity. Ano yan? Ang weight ng cab ay 5,000 pounds. At ang kanyang G ay 32.2. 32.2. Slug 32.2 feet per second squared. Now, yung pounds, yun na yan. Compute natin. 5,000 divided by 32.2 acceleration due to gravity. No? Compute natin. Okay, that will have to be 5,000 divided by 32.2 is 155.28. Repeat. 5,000 divided by 32.2. 155.28. 155.28 pounds per feet per second squared. So, ang gagawin mo dyan, after makuha mo yung, ano, or, ang ibig sabihin niyan ay 155.28 slugs. Okay, nagkaganon. Kasi, ito yung mass ng gap. Bakit slugs? Kasi, yung pound, equivalent siya sa slug feet per second square. So, yung pounds naging slug feet per second square, kasi yung feet per second square, matitira yung slugs. Now, pwede naman, ito na yung kunin natin. So, you have 155.28 pounds per feet per second squared. So we can have this cancel. So computation, your acceleration, maximum or permissible upward acceleration would have to be 8,000. That's divided by your previous answer. 51.52 feet per second squared. 51.52 feet per second squared. Okay? Just in case you wanted to have translated, divide by 3.281. So that is equivalent to 15.70 meters per second squared. 15.7. Yung kanyang equivalence. So that is approximately 55 kilometers per hour. Kasi 15 and it's 36. Around 55 kilometers per hour. 55 kilometers per hour per second. So that's it. For problem number 1, the maximum permissible upward acceleration will have to be 15.7 meters per second squared or 51.52 feet per second squared. Okay? So that's it for number 1. So we proceed with number 2. And as for number 2, is our problem number 2. Okay? A steel tube 12 feet long is used to support a sagging floor. So the inside diameter of the tube is 3 inches and the outside 4 inches. A sensitive strain gauge indicates that the tube's length decreased by 0.004 H. What is the magnitude of the load, considering that the Young's modulus for steel is 3 times 7 pound per square inch? In this particular problem, bali gumamit ng steel tube bilang pangsuporta sa isang sagging floor. Since tubular yung material natin, so hollow yung kanyang loob, kaya meron tayong outside inside diameters. It was said that using a sensitive measuring device, nalaman na na-compress o nagkaroon ng na-shorten yung ating steel tube by 0.04 inch. Then it has to, ano ba yung load? Gaano ba kabigat yung load? So, tinatanong sa akin yung weight ng load. Considering na yung modulus ay 3 times 7 PSI. Tuloy na dito. Bale, illustratively, we have parang ito yung floor. Sabihin natin yung load. Then supported by the tube. So, ang nangyari kasi, dumadagan kasi yung weight ng load. Dahil parang ating tube, ating tubo, ay makompress. Kasi ang naranasan ng tubo, yung ating tubo is subjected to two equal and opposite forces. Yung force, sabihin natin ito yung normal force, ito naman yung weight ng load. So we understand na the weight of the load is equivalent to the normal force. And that is the one nagkakahinaan, yung weight ng load. Tapos, binigay kasi sa atin, una-una, yung original length ng steel tube, which happens to be 12 feet. 12 feet. Yung kanyang inside diameter, 3 inches. Outside diameter, 4 inches. So, hindi pwedeng masasubtract lang natin yan. Tapos yung kanyang change in length, 0.004 inch. Knowing na Young's modulus daw ay 3 times 10 to the positive 7 PSI. Yan daw sa atin, ano yung weight ng load. So, pwede natin gawin din mga years that pwede tayo mag-start dun sa formula ng ano ba ang Young's modulus? Ang Young's modulus ay tensile stress over tensile strain. Ang tensile stress lang natin ay force over area. Ang tensile strain naman ay change in length over original length. Now, pwede natin kasi, i-derive natin yung formula ng force. So, solving for the force would have to be ito kasi ay magiging FLO over A delta F. So, magiging F equals Young's modulus times cross-sectional area times the change in length over original length. So, ito yung magiging working equation natin. To solve it for F. Kasi ano ba yung nalaman ng F? Kasi yung F, yun na yung weight na load. The one being asked. So, ang gagawin natin is to solve for F. We do have the value for Young's modulus. Meron tayong change in length. Meron tayong original length. Wala tayong cross-sectional area to. So, until we solve for A, saka pa lang natin makuha yung F. Nakasunod natin yan. Now, paano yung sa area? Para sa area ng engineer, ang gagawin natin area, yung area kasi yung contact. Ito yung may contact. Yung shaded portion na yan. Ito lang yan. So, we need to solve for that area. And that area happens to be your outside diameter minus the inner diameter. No, I mean outer area minus inner area. So, outer area would be pi d squared over 4 minus pi di squared over 4. So that would have to be pi over outside diameter 4 squared minus inner diameter 3 squared inch squared. So that pi over 4 quantity 16 minus 9 inch squared. So lumalabas na ang gagamitin natin area would have to be 16 minus 9 is 7. 7/4 pi inch squared. Okay? 16 minus 9 is 7. 16 minus, okay? So, what do we do next? So, gagawin natin, sasubstitute na tayo ng values knowing na para sa mga unit. Okay. So, solving for f, that have to be substitution of the copy. Young's modulus, area, change in length over original length. Okay, so substitution. Ang Young's modulus ay 3 times 10 to the 7 pound per square inch. That's the cross-sectional area. 7/4 pi inch squared times the change in length 0.004 inch, all to be divided by original length 12 feet, which needs to be converted to inches, so that would have to be 12 inches in 1 foot. Diretsong conversion na. So, cancelled yung feet, cancelled yung 1 inch, cancelled yung 2 inch squared, lalabas ay pounds. Okay? So, computation. So, 3 times 7 pounds times 7/4 pi times 0.04 to be divided by 144. Okay, mga values natin. 3 times 10 to 7 pounds times 7/4 pi times 4 times 10 to the negative 3 over 144. So we can have this cancel yung times 10 to the 7 sa yung 3. So may 4 na lang ito. So computation. 3 exponent 3 exponent to the 4 times 7 times shift pi because we can have this cancel 4 and 4, this now becomes 1. Equals divided by 144. 4581. 4581.49. Repeat. So 3 exponent 7 times 7 divided by 4 times shift pi times 0.004 divided by 144. 4581.49. 4581.49 pounds. Okay? Yun yung F. So, lalagay natin na since F is equal to the weight of the load, therefore, the weight of the load is equivalent to 4581.49 pounds. Okay, so that's it for problems 1 and 2.